All right, let's go ahead and discuss piecewise functions. Piecewise functions is going to deal with some of the stuff we talked about with inequalities, simply because piecewise functions are going to have inequalities embedded within them. So what a piecewise function is it is a function. So we have our regular functions, which is either y equals or f of x equals, right? Either one of those. And a regular function is just something on this side, okay? So this could be y equals x plus 2, or f of x equals, 2x minus 3, or whatever, right? There's just one thing. A piecewise function is when there are different pieces of the function for different parts of it. So an example of this, which I mentioned an example of it in the inequalities video, but an example of this would be if we had something like y equals, and then we'll usually see something like this, one of those fancy brackets. And so one case would be y equals, well, let's just go with the ones I just said. X plus 2 or 2x minus 3. And it's going to give you a use case for each of these. So it might say if, let's see, this one might be x greater than 1, and this one might be x less than or equal to 1. So what this is saying is everywhere on our graph where the x value is greater than 1, it follows this top equation, this part right here. And everywhere on our graph where x is less than or equal to 1, it follows this bottom equation, which is this part right here. So for an example of this, I've gone ahead and gotten this coordinate grid, which should work okay for us. I'll just scoot me down here. There we go. This says that it wants y equals x plus 2 when x is greater than 1, and y equals 2x minus 3 when x is less than or equal to 1, okay? Well, the point that I'm going to start at is x equals 1, and I'm going to check that for both of them. So in the top equation, if x equals 1, x plus 2 is equal to 1 plus 2, which is equal to 3, right? So this tells us that if we were to follow this top equation, then at the x value of 1, our y value would be 3. So what we can do with that, which is, we now have this ordered pair for a point, is we can plot that. But notice that we have a greater than sign, not a greater than or equal to sign. That means, just like when we talked about in our inequalities, that we need to do an open circle. So at the point 1, 3, I'm going to find that. I'm going to draw an open circle. Okay? Now I'm going to do the same thing for the bottom equation. That gives us, with x equals 1, it'd be 2 times 1 minus 3, which is going to equal 2 minus 3, which is going to equal negative 1. That gives us the point 1, negative 1 for the bottom equation. Now the bottom equation has x is less than or equal to 1. That means that it gets a filled in circle at its point. So the one that has the or equal to part, denoted by that line underneath our inequality sign, gets a filled in circle. So we have 1 and negative 1. It's going to be right there. Okay. And so now I have a point to start at for each of those. Okay. And from there I can plug in some more points to see what the rest of this graph looks like. So I'm going to erase this work right here, and I'm going to do one more test point for each one, because we really only need 2 points to graph a line, as long as it's a linear line. And since we don't have any like x squareds or anything like that, these are both linear. So looking at the top one, I need a point that's greater than 1 to plug in. Well, 2 is greater than 1, so that'll be pretty easy, right? So I'm going to plug in 2 for x. That gives me y equals 2 plus 2, which gives me y equals 4. So it's the point 2, because that was the x we plugged in, and 4. All right. This is now a filled in circle. That one first circle at the point that's given to us by here, that's the only one that's going to be an open circle. The rest of them are going to be filled in. And so now that I have 2 points for this one, I can graph a line through it and see that this part of the graph is going to go like that. Okay? For the other one, I need a point that is less than 1. Well, the easiest point to use that's less than 1 is always going to be 0. So for x equals 0, we plug it into the second one, because that's less than 1. That's going to give us y equals 2x minus 3, which is going to give us y equals 2 times 0 minus 3, which is going to give us 0 minus 3, which is going to just be negative 3. So this is the point 0, negative 3. Which means I'm going to plot this point again. It's 0, so it's on the y-axis, and we just go down to negative 3. And now I can plot, or draw my line down there. So in general, this is what this graph is going to look like. We have, and all that it is that we have 2 pieces of a graph that come together and make one graph. So the before x is 1, remember these are x values right here, negative 5, negative 4, negative 3, and so on. So before and up to the point where x is 1, which is right here, it follows the graph of 2x minus 3, which is going to be this one right here. After that point, it's going to be greater than 1. We can see that down here. Any space after this is greater than 1, so all of that. So after that point, it follows the graph x plus 2, which is this graph right here. So it's taking the pieces of these 2 different graphs in these parts of them and putting them together to form one graph. And you can have multiple piecewise equations. For instance, this could have had one that said, this could have said, whoops. I'm just going to move this over a little bit. This could have said this, okay? And then this could have been an even bigger bracket. And then we would have just had negative x when x is less than 0. So if that was the case, what that would mean is when it's greater than 1, it follows this graph. When it's from 0 to 1, it follows this graph, which would mean this one would just go between these 2 points from 0 and 1. And then when it's less than 0, it follows this graph, which is going to look like this. We would have a point there, and then we'd have an open circle there. And it would go on like that. So you can have piecewise equations that have 3 or 4 parts. I think that 2 or 3 is what you're going to deal with the most. But hopefully that makes it make a little bit more sense. Now the other, and notice again, this middle graph kept its filled in circle right there because we also have another or equal to. So anyway, as I was saying, the other thing that you might have to deal with the piecewise equation is not graphing it, but instead like solving something in it. So I'll make up something else. Let's say y equals 4x plus 2 when x is greater than 3, and y equals negative x minus 1 when x is less than or equal to 3. Okay? So what it would say is something like, what is y equal to when, and then it would say like when x equals 3, when x equals 5, and when x equals 1. Okay? And it would give you some blanks for these or something like that. So all that this would do is you're just plugging in the x value in the place it goes. For 3, let's look at it. The top one says it's 4x plus 2 when x is greater than 3. Well, 3 is not greater than 3, so it doesn't fit in this top one. The bottom one says y equals negative x minus 1 when x is less than or equal to 3. Well, 3 isn't less than 3, but it is equal to 3. So we would plug this first one into the bottom equation, which gives us negative x is 3 minus 1, which gives us negative 4. So our first answer is going to be negative 4. For the second one, we're looking for when x is equal to 5. 5 is greater than 3, so I would plug it into the top equation, because that's what happens when x is greater than 3. That gives us 4 times 5 plus 2, which is just the top equation with the x plugged in. That gives us 20 plus 2, which is equal to 22. The last one is 1. 1 is less than 3, which means it fits into the bottom equation. Plugging that in, we get negative 1 instead of negative x minus 1, so it's going to be equal to negative 2. So those are really the two things where the two different cases that you should have to deal with piecewise functions is either when you're given the piecewise function and you have to graph it, or when you're given the piecewise function you're asked to plug in different parts to it. So yeah, that should be pretty much everything with that you should have to do with piecewise functions.